Hello everyone, welcome to the channel MyOneTeacher. So in this video, we will solve this pair of equation. So the sums look very easy. Maybe some students are thinking we can easily apply elimination or substitution method and we can find the value of x and y. But it's not that easy. Let us try. Suppose if we apply substitution method, that is, suppose this is equation 1 and this is equation 2. And from 1, if we find root x as 7 minus y, that means x will be 7 minus y whole square. That is 49 plus y square minus 14y. We had applied a minus b whole square here. So if we put this value of x in equation 2, we will get 49 plus y square minus 14y plus root y equals to 11. Now, see, root y is there, y square is there. So let us do one thing. Let us take y as root y. Let's take root y as m. So this will become 49 plus, see, y square will be m to the power 4, because root y is m, so y will be m square, so y square will be m to the power 4. So this will be our equation. Now see, the degree is 4, so it's very difficult to solve from here, so that we cannot apply this method here. So let us try in a different way. Okay, let's start this. Now remember, we have to solve for x and y, where x and y are integer, as I have written here. So let's do one thing. Let us take p as root x and q as root y. If we do so, p is root x, so p square will be x and q square will be y. Now if we substitute this two value on equation 1 and equation 2, we will get p plus q square equals to 7, and from equation 2 will become p square plus q equals to 11. Okay, now let's do one trick here. The second equation, this one, can be written as p square plus q. Let us write 11 as 7 plus 4. Why we are doing that? Because if we take this as equation 3 and this one as equation 4, we can substitute 7 as p plus q square from equation 3. So this will become p square plus q equals to p plus q square plus 4. Now let us simplify this. So this will become p square minus q square plus q minus p equals to 4. I have taken all the p and q in the left hand side. Now p square minus q square in the form of a square minus b square, so can be written as p minus q times p plus q. Now from q minus p also we can take minus 1 common, so we will get p minus q. Why we have done this? To take p minus q common. Now from here, if I take p minus q common, I will get p plus q minus 1, which is equals to 4. Now product of two number is 4. Now 4 can be written as either 1 times 4 in the form of factor, or 2 times 2, or 4 times 1. So we can assume either this one is 1, this one is 4, or both are 2, or first one is 4, second one is 1. So let us check. Now if we take p minus q as 1 and p plus q minus 1 as 4, and if we solve this, we will get 2p q q will get cancelled, minus 1 equals to 5. So we are getting 2p equals to 6, so p equals to 3. Now if p is 3, let us check what will be x. So if p is 3, x will be 9. Now let us check q. Now if p is 3, q will be 3 minus q equals to 1 from this equation. So from there we will get q as 2. Now if q is 2, y will be 4. Both are integer, so this can be the solution. Let us check the other one also. If both are 2, I can say p minus q is also 2 and p plus q minus 1 is also 2. Now if we add this, we will get 2p, q will get cancelled, minus 1 equals to 4. So 2p is equals to 5 and p will be 5 upon 2. You can see p is not an integer. If p is not an integer, so x will also not be an integer, but it's given in the question x and y should be integer. So this is not the possible solution. So we can neglect this second one, that is 2, 2. So till now I got a solution 9 and 4. X as 9, y as 4. And the second option we can neglect because we are not getting an integer. This one you have to try and answer me in the comment box. Hope you have enjoyed this video. Let's meet in another video.